before. Now, the reason that this one's a little bit different, can anyone spot something special about my labeling? Maya?
Well, that one, like, it's sort of kind of upside down, and also, like, the, things over there, and also the 50's, like, still on the longest one, is that still?
That's okay, remember we can label the hypotenuse and one of the short sides. There's something else different and special about my label. Sarah?
The measurements are different. And
How do you mean?
1 centimeters and 1 millimeters.
Good. Oh. So it's more the units, isn't it? The units are different. Okay? So all of the others, the units have been the same. So it's really important when you're doing any question to check the units, because sometimes they're going to be sneaky and they're going to put different units in. Alright? So the first thing you have to do is to change them to be the same units. Now you have a choice. You can either change them both to be centimeters, or you can change them both to be millimeters. Neither is better than the other, okay? It may say in the question what unit they want the answer in, but it's unlikely. So we need to, as a class, decide which one are we going to change them to. Are we going to change them both to be centimeters or both to be millimeters? Do you have a question, Abby?
Well, to answer the question.
All I've asked is which do you want, centimeters or millimeters?
Yes.
Oh, you've had your hand up for like 10 minutes on answering that, okay? Which would you prefer?
Centimeters.
Centimeters, okay, so we're all happy to change them both to be centimeters?
Yeah. Smaller.
You want to change to the smaller? I mean, if we change it to the smaller unit, it means we're going to avoid decimals.
Oh, yes.
Which is sometimes nicer. So
Yeah.
it may be preferable to change them both to be the smaller unit, in this case will be millimeters. Alright?
Yeah.
So if we've got 2.5 centimeters, how many millimeters is that? Remember, we need to remember our chart, so we're going to picture our chart. How do we change something from being a centimeter to a millimeter? Do we multiply by 10, 100, or 1,000? Jade?
10.
10. Okay, so we're going to do 2.5 multiplied by 10, which gives us, Kyla? No, you do not need a calculator, young lady. We are multiplying by 10. So what happens when we multiply a number by 10?
Oh, yeah.
We add it. Well,
The decimal
if there's decimals in there, remember it's more the decimals.
It's 25.
Good girl. So this will be 25 millimeters. Oh, yeah. Okay. So we're now in the same unit, so now we can write our Pythagoras statement. So we choose a letter for our missing length. I've been using X all the time. You can use whichever letter you prefer. So I'm going to start with X squared equals. So remember, our first question is, are we finding a short side or a long side? Because that's going to decide if it's going to be a plus or a minus. So is it a short side or a long side? Well, remember, you're looking at your diagram. So for this one, you say, right, okay, I've got the length opposite the right angle. So I've got my hypotenuse, so I know it's going to be a subtract. So do we have our hypotenuse here?
Yeah.
So that means it's going to be a subtract. Are you all happy with that? So they're the questions that you want to ask yourself. Have you got the long side? If so, it's going to be subtract. So we now need to say, well, which number are we going to start with? We're going to start with the 50 or the 25? 50, because that's the bigger, so it's going to be 50 squared.
25.
Subtract 25 squared. And then to find x, Maya, this was something we got there in the end. If we have the answer to x squared and we want to find x, what are we going to do to it? What's the opposite of squaring something? Can you remember? The opposite is squaring. Not divided by 2. That was said the other day as well. That's the square root. Remember that? That funny tick thing. So we're going to now find this. Oh, maybe we should write what the answer is. What's 50 squared subtract 25 squared?
25
Square.
No, it's
175.
1.875.
And then to find x, we're going to find the square root of that.
How is it squared then? Wait, no, but isn't it 18.75? It's 43.30.
43?
Yeah, 43.3.
So, Sarah, we know it wouldn't be any decimals, sweetheart, are because neither of these two are decimal numbers. So when you are squaring them and putting them in the calculator, you wouldn't have 0.75 here.
Oh, I did it that way.
How did you do it?
So if I did a plus b squared equals c squared, then it's 2.5 squared plus b squared equals 50.
But darling, okay, right, you kept it as 2.5. Remember, we have to change the unit. Remember, we just talked about at the beginning of the lesson?
So,
So you mustn't leave it as 2.5. You've got to use it as your new number. You've got to put 25. Okay? Or you have 2.5 squared, and this one would be just 5. Okay, so you've got to make sure they're in the same unit. You can't have mixed units. So do you have your calculator? So we'll practice with the calculator which buttons to press. Okay?
can you just put that into there?
Yeah.
Miss, do you always have to change it back to? Because when you first type in the 175 square root, it has 25 square root 3.
Oh yes, so
Do you
remember,
always have to?
yeah, so we will always put it as, well, when I say always, at this stage we'll put them as decimal numbers. Later on in your schooling, you're going to learn more about those types of numbers with the square root sign, and you might leave it like that, but for now we want them as decimal.
Okay.
Okay? Right, so are we good with that? Yes? So remember, if you don't have the long side, so that's the question you ask yourself, do you have the long side? If you don't have it, you're going to be plus, and if you do have it, it's going to be subtract. All right, last example we're going to go through for now. So, we tend to not like these ones, do we?
If you don't have the long
Because-
side, you can.
If you don't have the long side, you can. Correct. Now, the reason we don't tend to not like these kinds of questions is because there's lots of words and there's no diagram. So, when it comes to these questions, best thing to do, draw yourself a diagram. Okay? Now, when I say draw yourself a diagram, those artists amongst you do not spend 25 minutes drawing yourself a diagram. Okay? I am no artist, so I'm just going to do the most basic shape, most basic diagram I can. So, question A. For both of these, it says at the top, find the length of the diagonal. Okay, we all know what a diagonal is? Yes? So it says, question A says a rectangle with length 12 and width 5. So a rectangle. So I'm going to sketch a rectangle. No, definitely not. It's a sketch, so you don't even need a ruler. Okay, it's a sketch. It's to have that visual thing in your head. Length 12, width 5. So I'm going to label this 12 and this 5. So far, so good?
Wait, a rectangle.
Rectangle. What did you draw, Caesar?
Square.
Oh, that's the next question. All right, so there's my rectangle. So what am I trying to find? I'm trying to find the
diagonal.
the diagonal. So where's the diagonal in this?
From the corner horizontal to the
Yeah.
top.
Like that?
Yeah.
Okay. You're happy with that? There are two diagonals, sweetheart. Just pick one. Because actually in a rectangle, they're going to be the same length. Okay? So I'm going to call that X. Now, the question is, Pythagoras' theorem only works for right-angled triangles. So can we see we've formed ourselves two triangles here? Are they right-angled triangles? That's our next question.
Yes.
Yes, because in a rectangle, all of the angles are right angles, aren't they? Now, I've only marked two of them, because the other one's been cut in half. Well, not half, but it's been cut up. Okay? So, what we're focusing on now is this triangle. Now, that is not a pretty triangle. Agreed? Does it matter? No, because it's given me that visual help that enables me to answer your question. I've got a diagram, I can see I'm trying to find this diagonal length, and I've got my two measurements on there. Okay? So that's the important thing when you're doing a sketch. Not, does it look the best thing ever? Have I measured everything? Nothing needs to be measured, you just label and make sure you've got an idea of what's going on. Sarah?
In the test so far, would you ever get a mark for doing that?
It's possible, it depends how many marks the questions were. Okay? So, there's my diagram. So, what was the question? The first question we have to ask ourselves, is it a right angle? Yes. Okay. Second question we have to ask ourselves is,
Are they measurements all the same?
are the measurements of the same units? Oh, I didn't write my units, but they are, yes. What's the next question we have to ask ourselves? Sarah?
Does the short size equal, does the short size equal the, hypotenuse?
How do you mean?
Does the size should equal?
Well, we have to first of all decide, have we been given the hypotenuse? Yes? So in this situation, no, we haven't been given the hypotenuse, alright? So our statement is going to start x squared equals, and are we going to be adding or subtracting? Adding, because we haven't been given it. Right. Does it matter which of the two numbers we start with? Can we start with the 12 or the 5? Does it matter?
Doesn't matter.
Doesn't matter. Okay, Kaya, what we're going to write then?
5 squared plus 12 squared.
Good girl. Okay? For the working, we don't need to put the units in. Don't panic about the units for the working. Alright, then we're going to get our counts and we're going to find out what 5 squared plus 12 squared is.
It's 144 plus 25.
169. And then how do we find x? What's that special thing to do? I'm going to keep asking it to make sure everyone always remembers. Jay?
We have square root.
It's a square root of 13. And at this point we can put our units back in.
It's hard I did all by myself.
Alright, so that was A. And now we have to do part B. So this time it's a square. Oh, Lord, love one in there.
What is that?
Alright, so we're going to draw a picture of a square now. Again, not pretty. Doesn't really matter. Mine looks a little bit more rectangular. Doesn't matter. It says side length 1. They've only given us one measurement.
They're all the same. They're all the same. It's a square.
It's a square, so they're all the same. So they're one eye tricking you then. We could label them all if you want. We don't have to. Again, we're trying to find a diagonal, so you can draw in either diagonal. I'm going to draw the same way as I did before. And we have to check, do we have some right angles here?
Yeah.
Yes, great. And so we're focusing on the triangle. We can label in the length we're missing. So, have we got the same units? Well, first of all, is it a right angle triangle? Yes. Do we have the same units? Yes. Do we have the hypotenuse? No. So we're trying to find that. So that means that we are going to be adding or subtracting m squared. We're going to be adding or subtracting. Good girl, adding. So what statement would we write? You can keep going. My asking is, this is your first lesson doing it. Exactly. 1 squared plus 1 squared. Now, I'm thinking, Pete, we don't even need our calc for this, do we? No. X squared equals, what's 1 squared? What's 1 squared? What's 1 plus 1?
2.
That was awkward. So x squared equals 2, so x is going to be the square root of 2. That is
1.41.
1.41. And
2.
you shouldn't have 2. Square root of 2.
So at the beginning it shows you square root. It shows you square root.
Yeah, 1.41.
Yes.
But then if they ask you for both the triangles, you just have to add.
Well, remember this, so in a rectangle, if we go back to this one, if this length's 12, that's also 12, isn't it? And if that length's 5, that's also 5. So it's going to be exactly the same. No, you wouldn't do anything, but like that's why you get the choice of either one, because they're exactly the same.
Maya.
Okay?
And there's no questions that will ask you to find both of them. Even
Well, no, because the diagonal would be the same length. And even if you'd gone this way, it would be still 5 and 12. Okay? Are we all good with that, ladies? All right, awesome. So we're going to have some practice